Molecular Biology from the Complutense University of Madrid, Cristina Sanchez.
Thank you. Thank you, Michael. It was a very nice introduction. Well, I, of course, want to start by thanking the organizers, Laura, Fernando, and the rest of the team. Thank you very much for inviting me again. And it's really a pleasure to come back to Lisbon and meet all the friends here and visit this city again. So thank you very much. And since we are going to be talking about cannabis and the endocannabinoid system for a couple of days, what I'm going to do is to make a brief introduction, a simple introduction of what the endocannabinoid system is and why it is so important in this conference and why we can use cannabis and cannabinoids to treat a lot of illnesses, a lot of diseases and symptomatology. So, before starting talking about the endocannabinoid system, I'm going to make a very, very brief introduction on the plant, on the cannabis plant. And as you all know, this plant, as many others, it produces a lot of chemical compounds, a lot of different chemical compounds that we, chemists or biochemists, classify in different families depending on how they look, depending on their chemical structure. Within this plant, as in other plants, we have a family of compounds that are called alkaloids, another one that is called flavonoids, terpenoids. But this specific plant produces a family of unique compounds that are mainly produced and only produced by this plant that are called cannabinoids. In this square here, I have put just two of them. The family is very big. We know about 170 cannabinoid compounds today. And these are the most popular one. This is delta-9 tetrahydrocannabinol. You will hear this name a lot during the conference. We call it THC. And this other guy here is cannabidiol, a CBD, which you will also hear a lot about today. And in the plant, these two cannabinoids are not present, or they are present in very, very small amounts. In the plant, they appear in these forms that you can see here. And if you compare these two molecules and these two molecules, the only difference is this group here. In chemistry, we call it carboxylic group or acid group. In other words, in the plant, cannabinoids appear in an acid form. And in order to get the active compounds, either THC or CBD, and this applies for the rest of the members of the family, we have to get rid of this group. And we can do that very easily by heating up the medicines or the cannabinoids or the preparation. And that's why in all the extraction processes, you will always include a heating up process. Or that's why we smoke cannabis instead of eating cannabis. So, which cannabinoids does this plant produce? And all the cannabis plants produce the same cannabinoids? Well, the answer is no. It depends on the specific plant. It depends on what people call strains. And all of the cannabinoids are produced from this mother compound, CBGA, cannabigerolic acid. And from this one, we can when I say we, I mean the plant can synthesize CBG type cannabinoids, a bunch of them, and from this CBG type we can produce CBD type cannabinoids, and cannabidiol will be included in this family. And from here we can produce different cannabinoids, as you can see here. And one of them is this other family, hydrocannabinol type, which includes THC. Why am I showing you this slide? I'm showing you this because each of these arrows represents an enzymatic machinery that produces the different families of cannabinoids. In other words, we can breed plants to produce more of these cannabidiol cannabinoids, or we can breed plants in order to have more of these enzymes, more of this machinery, and the result will be plants that produce more THC than CBD. This is very important because you will find a lot of different strains out there, and the difference between them is the amount of these arrows that they have, or in other words, the amount of the final products that they produce. And you can change that by breeding programs, and also by manipulating genetically the plants. And that gives you a lot of versatility in terms of producing different cannabis plants and therefore different cannabis medicines. But also very recently it was published, this paper was published in February, at the beginning of this year, in a very, very prestigious scientific journal, Nature, where the authors described the production of cannabinoids, all of the ones I've shown you before, in yeast, meaning that we don't need the plant anymore to synthesize these cannabinoids. We don't know how useful these techniques are going to be, but you are going to witness with all of us the growth of these new techniques to produce synthetic cannabinoids. So in addition to cannabinoids, the plant produces other compounds like terpenoids or terpenes. Here you have a few of them, pinene, limonene, and these are the responsible for the smell and the taste of the plant. But also they are important, and they are becoming more and more important because they produce some effects as well, and some of them have therapeutic value. And also because they have effects on mood, and this is very important, and I'm not going to get in detail into this because Mara Gordon is going to give you a whole presentation talking about the entourage effect, and she will mention that in detail. But what I want you to know is that when we work with the plant, we have to change our vision of medicine, because we're used to, and now when I say we, I mean doctors, they are used to think about medicine in terms of one chemical compound with one target that produces one effect. When we talk about cannabis medicine, this concept is completely different. We have a lot of compounds within the same preparation, meaning different molecular targets, meaning a variety of different effects. This is a challenge for the medical community, but it's an advantage because the doctors are using a cocktail of different protein, of different drugs to treat different things. And we can do that with one preparation, with the same cannabis preparation. And when we work with cannabis compounds, we also observe what is called in pharmacology synergism, which means that when you add the effect of one compound to the effect of another compound, the result is not 2, it's greater than 2. This is what we call the entourage effect. And also, when you combine different compounds within a cannabis preparation, some of those compounds can attenuate the negative side effects of the other constituents of the compound. So for all these reasons, it is way more interesting to work with whole plant preparations than with isolated compounds. It's more challenging, of course, but it's therapeutically is better. So how do these compounds produce effect? Well, they produce effects in our bodies because we do have cannabinoid receptors. And these receptors are molecules that are in the surface of our cells that bind, specifically bind these cannabinoid molecules. The first of these receptors that was discovered was named CB1, and it was discovered almost 20 years ago. And it's expressed, we can find it in the central nervous system, the peripheral nervous system, in the periphery, it's all over the place. We have CB1 receptors everywhere, basically. This is an image of a slice of a rat brain. If we do the same with our brain, with human brains, the result will be basically the same. And in this technique, the authors stained, they colored the CB1 receptors. So the darker you see an area, the more amount or the higher amount of CB1 receptors is expressed. And as you can see, we have huge amounts of CB1 receptors. For example, in these 3 nuclei here, these are what we call the basal ganglia. And this is the part of the brain that is in charge of controlling, for example, cognition, memory, emotion, and movement. So that's why when we use cannabis, we affect all these things. When we use cannabis, we have an impairment in short-term memory, for example, reversible, but an impairment of this kind of memory. We have an effect on our emotions. We have an effect on our motor coordination. And that's because we have targets in the areas of the brain that control these functions. For example, we have a lot of receptors also in the hypothalamus, which is this region here. And this is the part of the brain that controls our body temperature. That's why when we use cannabis, our temperature drops. Or it controls also energy balance. And that's one of the reasons why when we use cannabis, we are hungry, we get hungry. And it is very important to know where do we have cannabinoid receptors, because if we know where they are, we know which functions can be targeted or modulated by cannabinoids, but it's also very important to know where we don't have cannabinoid receptors. And if you see this image, there is a region, a very large region, which is this one, the brainstem, that does not express cannabinoid receptors. Here, there are no CB1 receptors. So whatever function is controlled by this part of the brain is not affected by cannabis use, because there are no targets. Which are these functions? These functions are the control of heart rate and breathing. And that's why there are no cannabis overdoses associated to deaths. So cannabis don't kill, because we don't have targets in these important parts of the brain. So CB1 is not the only cannabinoid receptor. A few years later, another receptor was characterized and described, CB2. And in healthy individuals and in adult individuals, this expression, the expression of the receptor, is restricted to the immune system. And I said healthy and adult because we have evidence that during development, we have CB2 receptors in places where once we get to the adulthood, it's not there anymore. And we also have evidence that in some pathologies, the CB2 receptors increase. So they are usually not expressed in certain tissues, but if the tissue is suffering a pathology, the CB2 receptors increase. So why do we have cannabinoid receptors? And I always say the same, but I think it's very, very easy to understand. Nature doesn't spend any energy in producing something that you may use one day in your life, that you may use in this case if you decide to smoke a joint. That's not how nature works. And if you think about it, for example, frogs, they do have cannabinoid receptors, and frogs are never going to be exposed to the cannabis plant. So why do we have cannabinoid receptors? Well, we have cannabinoid receptors because we produce something in our bodies that interacts with these cannabinoid receptors. And those molecules are called endocannabinoids. Endo because they are produced endogenously. And the main ones are these two guys here, anandamide and 2-AG. And for those of you with a chemical background, you will see that they are both arachidonic acid derivatives. So they are lipids, they are fats. And we also know how these lipids are produced, because you have to think about this system not as something that is constantly produced in the body. We don't have high levels of anandamide in the body all the time. We have high levels of anandamide in the body when we need high levels of anandamide in the body, like with adrenaline or like with any other signaling molecule. So we need a machinery that produces the endocannabinoids when they are needed, and also a machinery that degrades, that gets rid of the cannabinoids when they are not needed anymore. And this machinery is characterized. We know which are the enzymes that produce the endocannabinoids and that degrade the endocannabinoids. This is a very, very simple scheme where you can see this. This in gray is the cell membrane, the surface of our cells, and we have lipids, complex lipids there that are broken down to produce anandamide when it's needed. And these two things here are the two enzymes responsible for that. And we have a similar system to generate the other endocannabinoid, 2-AG. The name of the enzyme is here. It's not important. The take-home message from this slide is that we have a machinery that produces endocannabinoids when we need them, and we know that machinery. And in the same line, we have a machinery that degrades the endocannabinoids when they are not needed anymore in the cell. And this machinery breaks down this molecule here, releasing the arachidonic acid part and the ethanolamine part. And the same applies also for the other endocannabinoid, 2-AG. So together, all these things that I have just introduced to you, the cannabinoid receptors, the endocannabinoids, and the machinery that degrades and produces the endocannabinoids are what we call the endocannabinoid system. And what is the function of this system? Why do we have an endocannabinoid system? Well, this system is controlling a lot of physiological function. Basically, all of the functions that you know. It's controlling motor coordination, controlling appetite, memory, and a long, long list of different things. For example, pain. And this is just an example. We have cannabinoid receptors and all the machinery that I have just described in the parts of the brain and the spinal cord that control pain perception. And that's why we can use cannabinoids to produce analgesic responses, because we do have targets in the parts of our body that control this physiological response. Where else do we have cannabinoid receptors? Well, in the brain, we have them in the areas that control motor coordination, nausea, appetite, emotions, and that's why we can use cannabinoids to prevent the nausea and lack of appetite that, for example, chemotherapy induces. That's why we can use, for example, cannabinoids to deal with anxiety, because we have targets in the part of the brain that controls that. We can use cannabinoids also to prevent the spasticity produced by multiple sclerosis, for example, because we have targets in the parts of the brain that control motor coordination. But we have cannabinoid receptors and the rest of the elements of the endocannabinoid system in other parts of the body, not only in the brain. And this is just a very brief summary. And we can find the endocannabinoid system in the skin, controlling skin cell proliferation, fat production, and the immune response in the skin. And that's why it's possible that one day we will know that cannabinoids are a good tool for psoriasis, for example. We have an endocannabinoid system in the immune system, controlling inflammation and things like that. In the muscle-skeletal system, controlling bone homeostasis, and I have osteoporosis, for example, and I am a cannabis user because I want my bones to get more dense, and I'm using cannabinoids as a tool for that. We have an endocannabinoid system in the reproductive system, in the gastrointestinal tract, in the cardiovascular system, so it's all over the place, and this means that we can target many different pathologies because the targets are there. So what is the mechanism of action of this endocannabinoid system? How do endocannabinoids work in all of these situations? I have classified the mechanisms of action in 3. And the first one, the one that we know most about, is neuromodulation. And what you have here is 2 neurons, 2 brain cells that are communicating with each other. They are sending messages from this one, neuron number 1, we call it presynaptic neuron. This neuron is sending messages to neuron number 2. We call it postsynaptic neuron. So if we make a zoom of this area here, the connection between the 2 neurons, we will see something like this. We will see a space between the neurons that is called the synapse. And this is the presynaptic neuron, and this is the postsynaptic neuron. So when this presynaptic neuron is activated, when we receive a stimuli, a visual stimuli, we touch something, we feel pain, when that happens, this first neuron gets activated, and an electric signal travels through the body of the first neuron and gets to the end and opens these channels, calcium channels, and as a result, a lot of calcium is produced here inside the cell. And as a consequence of that, neurotransmitters, and when I say neurotransmitter, I talk about dopamine, glutamine, GABA, all of those, they are released into this synapse, into this space, interneuron space. And in the second neuron, we have specific receptors for this neurotransmitter. We have receptors for dopamine, we have receptors for glutamate, we have receptors for GABA, and they get activated and they initiate a response in the second neuron. And that's how our brain works. We receive a stimuli, one neuron receives the signal, and this signal is transmitted to a second neuron that sends the order to the muscle or to whoever has to act. What is the role of the endocannabinoid system in this scheme? Well, when this receptors are activated in the postsynaptic neuron, a signal is sent to produce endocannabinoids. And these endocannabinoids, the machinery that I mentioned before, remember? Enzymes acting sequentially to produce endocannabinoids, so they get activated, and we have an increase in the levels of the endocannabinoids. And they travel backwards to bind to their specific receptors, to their CB1 receptors, which are located in the neuron number 1, in the presynaptic neuron. And when these receptors are activated, they close these calcium channels that were open in the first place. Remember, that was the signal that triggered the whole thing, these calcium channels opening. So what cannabinoids do is closing these channels. And as a result, all this communication is shut down, and the neurons become silent. So what cannabinoids do is to silence neurons that are communicating to each other. And that's what we call them neuromodulators. They are not called neurotransmitters, but neuromodulators. And this is the main mechanism of action of cannabinoids. Most of the effects that you know about these compounds are produced by modulating this kind of signaling. In other cases, they control directly the expression and the activity of certain proteins, and I'm not going to get into detail in here. But a third mechanism that is very, very important, and specifically in certain pathologies, is their antioxidant activity. And this is the structure, the chemical structure of cannabidiol. And if you compare this one with this, and this is vitamin E, vitamin A, and tocopherol. These are the most potent antioxidants that we know. And if you compare the structure with that of cannabidiol, it's very easy to see that they look very similar. So cannabidiol also is a very, very potent antioxidant compound. And some of the therapeutic effects of CBD are produced by its antioxidant capability. So this is just an example, and someone else is going to talk about pain in detail. So this is just an example for you to see that when we work with cannabinoids, we are targeting many different functions. And as a result, we have a very, very efficient therapeutic response. So the example is focused on pain and how we perceive pain. And in summary, we have pain sensors in our skin, in our joints, in our GI tract, in all the places where you can feel pain. So when we receive a pain stimuli, this is received by these cells, by these sensors, which are neurons, and they send the message. This would be the equivalent to neuron number 1 in the previous slide. So this message is sent to the spinal cord, and this is the connection that I had zoomed in the previous slide. And this message is sent to a second neuron, the postsynaptic neuron, that travels through the brain to the specific areas in the brain that control pain perception. So that's how the pain signal travels through the skin, for example, if we are burning our skin, our hand, to our brain. So in this system, where do we have cannabinoid receptors? Well, we have cannabinoid receptors in the terminals, in the skin, in the joints, in all of those places where we can feel pain. We also have CB1 receptors in the spinal cord. And we also have CB1 receptors in the brain, in the areas that control pain perception. So when we use cannabis, when we use cannabinoids, we are targeting these receptors, and these receptors. And as a consequence, we feel less pain. But not only that, we also have CB2 receptors. Remember that they were associated to the immune system. So we have CB2 receptors in the immune cells that are in the brain, which are called microglia, and also in the immune cells in the rest of our body. And the immune cells are responsible for the inflammation processes. If we use cannabis, we can reduce all this inflammation process, and therefore the pain perception is reduced. But not only that, we also have CB2 receptors in the areas of the brain that control mood. And when we use cannabis, we feel a little bit of euphoria. And if we are feeling pain, feeling euphoria is great because we forget about the pain. And we also have CB2 receptors, as I mentioned before, in the parts of the brain that control short-term memory. And when we use cannabis while having pain, we forget about the pain. So as you see, when we are using cannabis, we feel less pain through different mechanisms of action. Through the reduction of pain perception per se, but also activating these other processes. Reduced inflammation, we forget about the pain and we don't care about the pain. So the whole purpose of the endocannabinoid system was defined a few years ago by Vincenzo Di Marzo, the guy that appeared in the video. And what he said 20 years ago is that our endocannabinoid system is there to make us relax, eat, sleep, forget, and protect. And these are very, very important things. If we can do all these things, we can have a very healthy life. And in other words, what he suggested is that the endocannabinoid system is there for us to keep our homeostasis, our internal homeostasis. And in fact, when we alter the endocannabinoid system, we can have some pathologies. Or more precisely, the endocannabinoid system is altered in several pathologies, which is not the same but saying that the alteration of the endocannabinoid system is the cause of a pathology. That's very important. But it is true that in some pathologies, we find the elements of the endocannabinoid system altered. And one of these pathologies is cancer. And this is just an example. I will talk more about this tomorrow. But in cancer, we see abnormally high levels of the CB2 receptors. This is a quantification of CB2 in normal breast, and as you can see in these bars, normal breast hardly express any cannabinoid receptors, any CB2 receptors. But when we take biopsies of breast tumors, we observe abnormally high levels of CB2 receptors, meaning that the endocannabinoid system in these patients is altered. Again, this doesn't mean that the increase in CB2 receptors is the cause of breast cancer. But in breast cancer, we see an increase in these receptors. So if the endocannabinoid system is altered in certain pathologies, how can we restore its normal activity to get a therapeutic benefit? Well, theoretically, we can follow two different approaches. The first one would be to block the endocannabinoid system. And this approach was followed by a company a few years ago. If you remember, I mentioned, and you know, if you have used cannabis or know anything about cannabis, that when we use cannabis, we feel hungry. So based on this, this company decided to use a molecule that blocks CB1 receptors to give to patients with obesity to try to make them lose weight. So the rationale is perfectly normal. It was, the clinical trials went very well, and this medicine was released to the market, FDA approved, EMA approved. And again, we were blocking the endocannabinoid system. We were blocking specifically CB1 receptors. But the CB1 receptors are not only in the parts of our brain, our guts that control appetite. They are also in the parts of the brain that control our mood. And we are happy when our CB1 receptors are activated. And on the other hand, we are sad when we block those receptors. And we are so sad, and these patients were so sad, that a lot of them committed suicide. And this product was withdrawn from the market due to those terrible side effects. So blocking the endocannabinoid system is not a good idea. Nothing that has been done so far to block the endocannabinoid system has given good results in the clinic. So this is not what people are doing, doctors, patients are doing. What they are doing is just the opposite. What they are doing is activating the endocannabinoid system. How can we activate the endocannabinoid system? Well, we can do it by different ways. The first one could be increasing the endogenous tone of our own endocannabinoid system. We can produce anandamide, so we can activate all these processes that increase our endogenous levels of anandamide and 2-AG, for example. How can we do that? Well, certain cannabinoids, and CBD is one of them, can increase anandamide level. And CBD does that by inhibiting this enzyme, which is the responsible for the degradation of anandamide. So if we block the degradation of anandamide, we increase its half-life and we have higher levels of anandamide in our body. And that's one of the mechanisms of action of CBT. Also, we can increase our endocannabinoids by massage and osteopathic manipulation, by acupuncture, by doing exercise, by using dietary supplements. For example, black pepper is a CB2 agonist. CBT is something that activates our CB2 receptors. But what we are going to focus on during these 2 days is another strategy to increase our endocannabinoid system activity, and is the use of exogenous cannabinoids. And we can go to the lab and synthesize cannabinoids, and we can do that, and that's relatively easy. But that has been done, and it's not working very well in the real clinic, in the real practice. So what is working, and what we will be focusing on, is the use of phytocannabinoids. Phyto meaning cannabinoids extracted from the plant, the cannabinoids that we extract from the cannabis plant. So, just as a summary of all what I said, we do have an endocannabinoid system. All of us sitting here have an endocannabinoid system. And this system is controlling many, many different physiological functions. And for this reason, and only for this reason, there's no magic around cannabis, it's science. And since we have an endocannabinoid system controlling this function, we can target the endocannabinoid system to get therapeutic benefit for a lot of symptoms and a lot of ailments. Thank you very much.
Thank you very much, Cristina. Fantastic.
So far, we don't have any questions on the app. So if anyone wants to place a question to the speaker, please be our guest. We have microphones available. And just raise your hand and we'll have a microphone ready for you to put the question. Yes? Can I have a microphone here? No? Oh, the app was not working.
Oh, there's one on the right. Yeah.
There was some technical issues. It's working now. Can you please check? It's working now. It's unstable.
We have an unstable app.
So let's do it this way. For this panel, please, I can have a note. Please raise your hand if you want to place a question, and we manage it this way. On the next panel, should be working.
Yeah.
There were some technical issues. If it's not, we keep managing it, placing the questions with the audience speaking. So, any question? Yeah, over there. Can I have a microphone? Yeah. I go the other way. Yeah.
Hi. You mentioned an increase in CB2 receptors for people who have breast cancer. I'm curious, is there any clinical trials currently happening to explore treatments for that?
I'm afraid there are no clinical trials ongoing, and that's what we are desperately trying to do. In order to do clinical trials, not only in breast cancer, but in anything else, we need doctors willing to do the trial, we need a product that they are willing to try, and we need a lot of money. And so far, we are trying to find the 3 pieces of the puzzle. We have been able to find 2, these are the 2, but we have never been able to find the 3. So the answer is no, there are no ongoing clinical trials, unfortunately, but that's our goal. I love doing basic research, but my goal right now is moving forward to clinical trials. So if you know doctors and you know a company that has a product and a lot of money and is willing to do a trial, please let me know.
Do you have any theories about what might work or what you'd like to try? What kind of products, cannabinoids, terpenes that would work?
Yeah, we would like to go. The first question is, are you coming tomorrow to the session? I will talk more about that. I will focus my presentation on breast cancer. But for now, the first question would be pure compounds or whole plant preparation? And the answer is whole plant preparations, for sure. I will be showing tomorrow results demonstrating that, at least in cancer, is a better therapeutic approach to use whole plant preparations than isolated compound. And the next question is which cannabinoids and which terpenoids, and for that we have to go to people that have experience in treating cancer patients. This is not legal in most parts of the world, but in some are, and we have people, and we have one person that will be presenting about that, Mara Gordon. She's been working with patients for 9 years already, and a lot of them are cancer patients. So she has experience in knowing which is what works best for them. But it will be something with both THC and CBD, not only CBD for sure, so THC and CBD. And the terpenoid selection, I'm not an expert. I mean, I would suggest you to ask her. She will be presenting in an hour or so, so I would suggest to ask her.
Thank you. Another
Any others?
question?
To the right.
Yeah.
Okay, thank you. Good morning. I wonder regarding one of your first slides for the different systems of receptors of these endocannabinoids. The one on musculoskeleton skeleton may be applied for diabetes, for instance, or osteoporosis, because you refer insulin and for these two problems, health problems. Is there any chance in the future?
I don't work in any of those two areas, but for what I know, for diabetes in particular, there are some cannabinoids that look very interesting. THCV is one of them, if I recall correctly. And for bone density, there are some studies, and not only preclinical, but there are some clinical studies also, showing that CBD activates the bone cells that produce bone instead of the bone cells that degrade bone. You know that the bone structure depends on the equilibrium between these two types of cells. So CBD in particular activates the bone forming cells. And that's why people are suggesting that this may be a useful tool for osteoporosis. I'm a user for that purpose. And also for bone fractures to recover faster. Yeah, but this is still a lot of work to do, but the results point in that direction. Welcome.
Thank you. Yeah.
Please stand up, please.
Sí, ya. Buenos días, Cristina. Primero que todo, un saludo. Welcome to everybody to this very interesting conference here in Lisbon. And my question is about food. For example, fruits, species, or something about food can help cannabinoids for work better in our body. I don't know if you can tell us or help us about what kind of fruits or species, something about food. You know, I received some information. Some food can help the cannabinoids for work better into our body. I don't know if that's true.
If I understood correctly, you're asking about food. If any type of food can help absorb the endocannabinoids?
Yes, it is. Sí, bueno, yo he recibido cierta información acerca de, por ejemplo, el mango o ciertas variedades de fruta que pueden ayudar más.
Yeah. There was a thing going on about mango and cannabis, and what I heard is that eating a mango before smoking cannabis would make you higher or make you high faster. But I was looking in the literature, I didn't find anything supporting that. That's what scientists say or don't say, because I didn't find anything. But something different is what users say. So I don't really know if that's true or not. And regarding other foods, as I mentioned before, there are some things other than cannabinoids that activate the endocannabinoid system, and black pepper is a perfect example for that. Black pepper has nothing to do with cannabis, but it activates the CB2 receptors. So for some things, the effect of black pepper could mimic the effect of cannabinoids. I mean, you don't get high by taking black pepper, but you can have some of the benefits of using cannabis.
Thank you very much. We've got to move on to the next speaker, but Cristina will be available. Thank you so much for the question. Thank you, Cristina, very much.
Thank you.